We have given continuous function f in this closed interval because sinus and cosinus is continuous. So to find absolute maximum and absolute minimum, we need to first find the first derivative of our function to find critical points. When we have critical points, we need to find the value of our function for these critical points and the value of our function for these endpoints. So when we have this, we have to choose the smallest and the largest values. So first derivative of our function f prime of x is equal. We have to find the derivative of square root times sinus. So square root we just copy of 3. Derivative of sine is cosine. We have x over 4 times we have to find the derivative of x over 4. We can rewrite x over 4 is equal 1 over 4 times x. So derivative of this expression is just 1 over 4. So we have plus derivative of cosine is negative sign, so plus and minus give us minus sine x over 4, and the same derivative of x over 4 is derivative of 1 over 4x is 1 over 4 plus derivative of 600 is 0, so we don't have to write. So this is equal square root of 3 over 4 cosine x over 4 minus 1 over 4 sine x over 4. Because the domain of our derivative is all real numbers, because domain of cosine and sine is all real numbers, so we don't have critical points. So now to find critical points, we have to set first derivative equals 0. This is equals 0 if and only if we have square root of 3 over 4 cosine x over 4 minus 1 over 4 sine x over 4. This is equal 0. First, I will move negative 1 over 4 sine x over 4 to the right side, so I will have square root of 3 over 4 cosine x over 4. This is equal 1 over 4 sine x over 4. Now I will multiply both sides by 4. So 4 we can reduce. So we have square root of 3 cosine x over 4. This is equal, I just make a mistake, we cannot reduce this 4, we reduce 4 with this 4, so we have equal sine x over 4. And now I will divide both sides by cosine x over 4. So we will have cosine, we can reduce. So we have square root of 3 is equal sine over cosine, and the same x over 4 we have. So this is tangent x over 4. Let me rewrite this. We have tangent x over 4 is equal square root of 3. Now we can substitute x over 4 by, for example, t. So we have to solve trigonometric equation tangent t is equal square root of 3. To solve this trigonometric equation, it's good to draw tangent. Doesn't exist for pi over 2. So this is t axis, this is our y-axis. So tangent for 0 is 0. This is our asymptote for pi over 2, and for negative pi over 2, the tangent doesn't exist. And tangent is increasing from negative infinity to positive infinity in this interval, open interval, and next will be for pi. We have tangent equals 0, and for 3 over 2 pi, tangent again has asymptote. For 3 over 2 pi, tangent doesn't exist, and one more time, tangent is increasing from negative infinity to positive infinity. So we have tangent t is equal to square root of 3. Square root of 3, this is approximately, you can write here, square root of 3. So we have to find these points for which t, our tangent, is equal square root of 3. And because tangent repeats every pi, so this solution repeats every pi. So when we find this t, so we just have to add pi to have next solutions. We can use calculator. We have to change calculator to radian, and we have inverse tangent of square root of 3 is equal 1.047. So t is equal 1.047, and like I said before, this solutions repeats every pi because tangent repeats every pi. So will be plus k times pi, where k is integer. It means has value 0, plus, minus 1, plus, minus 2, and so on. So now we have to come back to our substitution. We have t equals x over 4. So x over 4 is equal 1.047 plus pi k. Now I will multiply both sides by 4 to reduce this 4. This whole expression I have to multiply by 4. This 4 and 4 will reduce, so we have x is equal 4 times 1.047. So this is equal 1.047 times 4 is 4.188 plus 4 pi k. Now we have to replace k by these integers and find critical points which belongs to this closed interval only. So for k equals 0, we will have x equals 4.188 plus 4 pi times 0, it will be 0. So we have 4.188. This belongs to our interval. So we have first critical point. This is okay. Next, for k equals 1 positive, so will be 4x equals 4.188 plus 4 pi times 1 is 4 pi. This is equal. Let's use calculator. So we have 4.188 plus 4 times pi pi. This is equal 16.75. This number is greater than 10, so it's not belong to our interval, so we can cross. Next, let's check for k equals -1. We will have x equals 4.188 plus 4 pi times -1. This is equal 4.188. Positive and negative will be negative 4 pi. This is equal 4.188 minus 4 times pi. This is equal negative 8.37. This number doesn't belong because we have only positive values from 0 to 10. So we can cross. So we have only one critical point which belongs to our interval. We have to find the value of our function for this critical point and for endpoints. So we have f of 4.88, 188, and endpoints are 0 and 10. F of 0 and f of 10 we have to calculate. So it means we have to replace x's in original equation by these values. So we have square root of 3 times sine. We have 4.188 over 4 plus cosine 4.188 over 4 plus 600. This is equal. You can use calculator. So we have square root of 3 times sine. In parentheses, we have 4.188 divided by 4, close parentheses. This is equal plus, we have cosine. In parentheses, 4.188 divided by 4, close parentheses, plus 600. This is equal 602. Next, we have to do the same for 0. So we have square root of 3 sine 0 over 4 plus cosine 0 over 4 plus 600. This is equal. Sine 0 is 0, so 0 times square root of 3 is 0. Cosine 0 is 1 plus 600. This is equal 601. Now we have square root of 3 sine 10 over 4 plus cosine 10 over 4 plus 600. This is equal. Let's use calculator. We have square root of 3 times sine 10 divided by 4. This is equal plus cosine 10 divided by 4 plus 600. This is equal 623.23. So now we have to choose the largest value. The largest value is 602 is for x equal 4.188. This is our absolute maximum. And the smallest is 600.23. This is our absolute minimum. for x equals 10. So this is my solution.